Hello, thanks for joining me today. We're going to talk about credential protection on F5's Advanced Web Application Firewall. One of the problems that we face today is that man-in-the-browser malware can actually collect and steal our credentials even before we can get them encrypted with TLS and sent along their way. So we're going to start out by looking at a couple of the ways that man-in-the-browser malware works to collect that data, and then we're going to look at some strategies for actually attacking that problem. Here we have a web application deployed behind a big IP. We have no security policies in place. Let's take a look at the logon page for that. So here's the logon page. If we go ahead and take a look at the username field, we can see here it's username is the name. If we look at the password field, name equals password. So there's no changes going on to the page. It's fully loaded. So we'll go ahead and just type in admin, and we could see, so we had some changes really quick here as we typed it in. Let's go ahead and load these tools. So this is JavaScript that functions really the same way that man-in-the-browser malware does. So we're going to start a keylogger right here on the password field, and I'm going to type in admin. Go ahead and watch up here. So you can see it captures those keystrokes as we put them in. We could also steal the password right out of the field. So right here we've just collected what we typed in. So those are two ways that malware in the browser can actually steal credentials, either with a keylogger or event listeners looking for perhaps as you move away from the password field to collect them. Let's look at a third way that it could do that. So we'll go ahead and sign in, and we'll go check the posted values here, and here's the parameters posted. So a post grabber could actually grab these values. All of this happens inside the browser before we encrypt it with TLS. So let's talk next about what we can do to prevent that from happening. We can use DataSafe to protect against that. So we'll go to Security, Data Protection, DataSafe Profiles, and we'll open up a new profile here. We'll go ahead and just name it DataSafe. And here under Events, we're going to go ahead and publish it to the local syslog. And then here under Advanced, if we wanted to trigger iRule events, we could do that if we wanted anything custom. We're going to go to URL list. We're going to add a URL. So in this case, /user/login is the URL we want to protect. If we needed a wildcard, we could do that. For the parameters, we saw that the parameters that we're going to protect are username and password. So if we wanted to identify a field as the username in our logging and our alerts, we could do that here. If it posts with AJAX, then sometimes the field name is not the same as the HTML form field name. So we could map the AJAX field name here if we needed to. And then here we can encrypt the values in a particular one. We can substitute the values, so we'll go ahead and do that for the password. We'd probably do it for both in production, but I want to show you the difference between the two. And then we could obfuscate the field names. So I'm going to go ahead and obfuscate password, but we're going to leave username field name in the clear for you. So we'll go here to application layer encryption. So if we were using AJAX, we would need to enable that. We aren't in this case, so we'll leave it disabled. We can identify stolen credentials. So when we substitute values, we can see if those are used. We can identify that as a problem. We can enable keylogger protection, real-time encryption, so we'll encrypt the values as the user's entering them. And then we'll do HTML field obfuscation. We're going to go ahead and add extra decoy inputs, and we're going to remove element IDs and listeners so that malware can't effectively track those fields. Then if we had marked that username field earlier, we would probably also want to mark this as a logon page. And we could identify what would tell us that it was a successful login when we identify that username earlier. So we'll click Create, and we're going to go add this now to the virtual server. So we'll go here to Security Policies, and we'll go to Anti-Fraud Profile. We'll enable it, and we'll select the one that we just added. All right, let's go see those protections in action. So we'll load up that same page. And we're going to go ahead and inspect the elements. We'll hit admin, type that in here. We'll load the tools. All right, So watch this field and you're going to see changes happening to it. That's because the page is dynamically changing constantly. That's those decoy inputs and the HTML field obfuscation. So there's some changes right there. We're going to start a keylogger and we're going to look at this field. So you can see that we're just spamming it with inputs. So you would never be able to identify the actual values input. If I try to steal this password, I just typed in admin, you can see now all we get is lowercase a's. So we've substituted the value. Now if we go ahead and go over here to network and we go to sign in, let's take a look at the values that were actually posted. So we'll look at post and we'll look at parameters. And this time you can see that we've left username in the clear so we can see that, but the value is encrypted just like we set up. And then we have a number of extra fields here beyond what we had before. That's decoy inputs. And we can't identify which one is the actual password field. And then the values are encrypted. So this is how we protect against the keyloggers, how we protect against something that's going to grab the inputs as we're entering them, and the post grabber. So let's try one more thing. Let's edit this and resend it. So let's say, for instance, that we had something that was actually going to modify these values and send username equals admin and password equals admin as the values. Now we'll go ahead and hit send. So we can see that we get in. We aren't blocking any traffic right now that hasn't gone through the encryption. So we'll go ahead back over here to logs, and we can actually see that event right here. We can see that here's a post to this value, and we got the real password field. So we know that we should have gotten that HTML field obfuscated location, and instead we got the field password. So we can identify that some tampering is being done there. So everything that we've just looked at here is done as a proxy on the big IP. When it comes back to the big IP, it's converted back to the normal things that the backend server is expecting. So it has no idea that this has happened, and the actual application's functionality is not altered. So that's data safe in action, protecting your credentials. Thanks for watching.